Hi guys, and welcome to this online lesson, much like the ones I used to do at Ed Rollo, but without me being physically present, or in fact on the screen. So previously, and this is building on the work we have done previously, you will notice that we are now going to be looking at solving equations. So at the end of the lesson, if you would be so kind as to complete that work, I would be grateful. And yes, homework is to make sure that you complete that work. So we've already worked out how to factorize equations, and if you remember, we are looking at equations being of the form, as we've written here, x minus 2, x plus 3. So this form is actually really important to us, and that would have been created from, and if I multiply this out the long way, I would have had x squared plus 3x minus 2x minus 6. So that would have given me x squared plus x minus 6. So having done the factorization, we would have ended up with it at this point. And if you remember, there is no real surprise that that value there equates to that value there, and the plus 3 equates to the minus 3 there. And again, that change of sign is something quite important. If you've already done this, my apologies, and you can probably just skip straight to the questions. But if you haven't, stick with me. So with the example above, we've seen that actually it's been factorized for us. As I say there, it's been factorized for us. But the important thing to remember is it should always be written as an equation. Equations are really important because they're effectively in a relationship. Not in a relationship, they are a relationship. How can equations be in a relationship? That's just wrong. All right, so realistically speaking, writing stuff like this is not the right way. It should be y equals 0, because that we are saying to find the y value, we only need to know an x value, and it's related to in that situation. Now, solving quadratic equations, we're actually finding where the graph crosses the line y equals 0. Again, here, if you remember, we know this is the x-axis, but it is also the point where all the y values are equal to 0. So if we want to know where all the y values are equal to 0, and we have an equation here that says y equals, then we can simply put 0 equals x minus 2, x plus 3. Now that to me looks strange. We generally don't write it in that form. We would normally write it the other way around. So you would have x minus 2, x plus 3 equals 0. That is the first stage to solving this equation. Moving on to the null factor law, that is to me the crux to all of this. So what is the null factor law? Well, as you've noticed, we've got something like x plus 2 and x minus 3 is equal to 0. Now, I know that's not the actual thing, but let's not have to get too tied in with these specifics. The point of it is, we use an idea that, effectively, that could be 0, or that could be 0, or they could both be 0. Now you're going to say, well, hold on a moment, what do you mean? Well, if you think about it, 0 times 2 is 0, 2 times 0 is 0, and 0 times 0 is 0. Now the fact of me using numbers makes no difference whatsoever. The point of it is, when I have an answer equal to 0, then what it suggests is, for that to be true, either that has to be 0, or that has to be 0, or they both have to be 0. And that's exactly what we use to solve quadratic equations. And as I say here in a slightly more colourful way, we use the idea then that either x minus 2 could be 0, or x plus 3 could be 0, or, as I say here, they could both be 0. Well, if that's the case, we can then split this up into a situation where we can say, well, if that's algebraically correct, then I can say that the first half of that equation, x minus 2, is equal to 0, or x plus 3 is equal to 0. And a basic bit of manipulation tells me, well, for that to be true, that means the x value has to be 2, or the x value has to be minus 3. Well, hold on a moment. That seems to make sense, because if we say x is 2 and x is minus 3, just so happens there is my value where x is 2, and there is my value when x is minus 3. And so, yay, by solving these things here, I've just actually worked out my x-axis intercepts, all right? So these two values here actually turn out to be critically important for later areas of mathematics, and in particular methods 3 and 4. So I suppose the question is, how do we solve these things from first principles? Here's an example. If we remember the t method, take the 2 and the negative 12 minus 24, right? Because at this moment in time, this is not in factorized form. There are 3 terms. And to turn 3 into 4, I need to be able to split up this plus 5x. So 2 times minus 12, finding the factors, minus 1 and 24, minus 2 and 12, minus 3 and 8. And in fact, I don't need to go any further because I'm looking for the factor pair, which when added together give me positive 5. And that is the situation. So, remembering that we're doing this to split that middle term up, the first term stays as 2x squared. The second term stays as, negative 12. That's still equal to 0. And so we've split that term up into now minus 3x plus 8x minus 12. Now, sometimes people ask me, is the order in which we write these in this equation actually important? And I say, well, yes and no. Sometimes writing them one way around will make the multiplication easier or the factorization easier, but actually you should still end up with the same result. So we now have 4 terms. How does that help us? Well, we now can split this up into factor pairs. And so what is the maximum that can come out of that? It would appear to be x, so I get 2x minus 3. And what's the maximum that comes out of these two here? Plus 4. And what do I get? 2x minus 3 equals 0. Now, one of the great things about this is you can check to see if you're on the right lines, because I am expecting these two things here to be exactly the same. Why? Well, I now have 2 terms. So if I have 2 terms, what does that tell me? Yup, it tells me that I can now factorize again because I've got something which is common. Therefore, move outside what is common and leave what's left is equal to 0. Have I finished? No, because, and a lot of people think that's my final answer. It isn't, because the question says to solve. And to solve, we have to use the null factor law, which states that either 2x minus 3 must be equal to 0, or x plus 4 must be equal to 0. 2x is equal to 3, x is equal to negative 4. Thank you very much, that's my final answer. And so x would be equal to 3 on 2. And again, I'm asked a lot, should we write it as a fraction or a decimal? My advice is most exams, and in fact for your Methods 3 and 4 exam, you have to write things in what we call exact form, right? So that's fraction or a whole number or a surd form. There is no value here in writing that as 1.5. Knowing this, I could theoretically now, if I'm being asked to, and as a hint, this will come up later, say, well, I have now one crossing point at -4. I have another crossing point at effectively 3 on 2. The question is, which way does the parabola go? Well, to help with this one here, because the coefficient in front of the x squared is positive, it means I'm looking for a beautiful U shape, which is going to look like that, roughly speaking. And if you remember, because this equation, this graph here, will actually have an intercept, we would be expecting to find that intercept, and maybe not, we'd be expected to find the minimum point. How do we do that? Well, you know how to find the minimum because there is an axis of symmetry through this thing here. How do we find this point here? Well, you've got the equation, if you remember, is 2x squared plus 5x minus 12. So 2x squared plus 5x minus 12. Now again, although we put it equal to 0, what you've got to realize that is for one specific case. That is only to find the intercepts here. Generally speaking, that actually says, there's my equation. To find the y value, I put an x value in, and lo and behold, what do I know about the points on this line? Not only is it called the y-axis, it's called the line, x equals 0. So when I put 0 into here, that disappears, and I find that my intercept is negative 12. Point of interest for later on, you must write intercepts in coordinate form. So that should be written as 0 minus 12, not just put minus 12 on there. Likewise, although that crosses through 3 on 2, it should be 3 on 2, comma 0, and that one there should ideally have expressed beside it minus 4, comma 0. So nothing particularly new here. Looking at you guys yesterday, you looked blissfully bored as I was explaining this stuff. So once again, any quadratic, when you solve it, it has to be equal to 0. Use the T method, split it up into 4 terms. Factorize. factorize again. Use the null factor law to split it up, putting both of those equal to 0, and thereby we have our final solutions. Where necessary, we would then, if the question had asked us, sketch that graph. And again, it doesn't have to be beautiful, it's not a work of art, it is there specifically to help you find out where the important point of the graph is. All right, as I said at the very beginning, that is the work that you need to do. So 1, A, D, E, G, 2, A, B, etc., etc., etc. Thanks very much for listening. I'll look forward to seeing you next lesson.